In this video, we're going to take a look at the 5 different triangle congruency conditions and how to identify the correct condition. So to start off, like I said, there's 5 reasons that triangles are congruent. The first is side, side, side. In order to identify side, 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 we are going to look for 3 pairs of corresponding congruent sides in the triangles. If you see something marked with 3 sets of tick marks, it's going to be side, side, side. Side angle side is where you have 2 pairs of congruent sides and the angle in between the 2 sides are also congruent, the angle pairs. Okay, so the angle has to be between the 2 sides for side angle side. Looking at angle side angle congruency, I have 2 pairs of angles that are congruent in both triangles. I also have a pair of sides that are congruent, and that pair of sides has to be between the 2 angles. Looking at angle, angle, side, again, I have 2 pairs of angles that match up, but this time the side is not in between the 2 angles. And lastly, hypotenuse leg involves a right triangle. So I can only use hypotenuse leg if I know my triangle is a right triangle, and then I would have to know the hypotenuses are congruent and one of the legs is congruent to one of the other legs. Sometimes we mix up our triangle congruence conditions with our triangle similarity conditions. So I wanted to take a minute and just refresh what it would look like if triangles were similar. I have 3 conditions for triangle similarity. The first is angle, angle similarity. In order to know 2 triangles are similar, all I need to know is that 2 pairs of corresponding angles are congruent. The second condition is side angle side similarity. And in this case, I would have to know 2 pairs of sides are proportional, meaning they have equal ratios. In this case, it looks like it's multiplied by 4. And I would have to know the angle in between those sides. The angle pair between those sides is also congruent. The third triangle similarity condition is side, side, side similarity. And that happens when I have 3 pairs of sides that are proportional. In this case, it looks like all my side lengths have been multiplied by 2, so my ratio would be 2 here. Okay, so again, those are the differences between triangle congruence conditions and triangle similarity conditions. Now let's take a minute and work through identifying some congruent triangles. It says for each pair of triangles below, determine if they are congruent. If they are, complete the correspondence statement, state the congruence property, and record any other ideas you use to make your conclusion true. Okay, so we're going to look at this first one here. It says triangle ABC is congruent to triangle, and I have to figure that part out. I see this angle here. I see this angle listed here. So I know of my 5 reasons. I'm probably looking at either angle side angle or angle angle side because I have 2 pairs of angles. When I look closely at this diagram, I see that I have this shared side here. Okay, that side is a shared side. In a proof, we would list that as the reflexive property, being congruent to itself. In this case, I'm going to use that side and then look at what I have. I have an angle, and then a side. The side is not between the 2 angles, so that is going to be angle, angle, side congruence. And then to finish my statement, I would say triangle ABC is congruent to triangle ADC. Let's look at part B. Looking at part B here, I see that I have these 2 sides here that match up. I also have this right angle here, which tells me these triangles are right triangles. And then I see this shared side here. Because these are right triangles, this is the hypotenuse and a leg congruent. So I would know that by hypotenuse leg congruence, I could say triangle SQP is congruent to triangle SQR. I would not say side, side angle. Side, side angle is not a valid triangle congruence condition. Sometimes we look at this and we say, oh, here's a side, and an angle. But in this case, it's hypotenuse leg because it's a right triangle. And that's a special case that works for right triangles only. Let's take a look at part C and what we are given here. I have a pair of angles that are marked congruent. And then I have a pair of vertical angles here that meet at M. Specifically, I would call them angle LMP is congruent to angle NMO by vertical angles, but I don't have any sides. Angle is not a congruence theorem. I do not know these triangles are congruent, so I'm just going to write not congruent. I don't have enough information there. We'll look at one more here. The only information it gives me in this diagram is that this point Y is the midpoint of WT and XZ. If it's the midpoint, it means it's in the middle. So I would know that WY is congruent to TY by definition of a midpoint. And I would also know that XY is congruent to ZY. And then again, I have these vertical angles here where these lines intersect. So this would be congruent by side angle side congruence theorem. And then I would say angle WXY, or triangle WXY, is congruent to triangle TZY to finish that statement out. I hope this was helpful for you to see the different reasons why triangles are congruent and also to identify congruent triangles based on the information you're given in a diagram.